Welcome to the language of probability distributions. In this video, we will look at a fair few definitions. And these definitions will need to be used as we go through this topic. So the first one, when we look at responses to surveys, we can have responses that can be quantitative, that's numeric, or categorical, which is worded responses. In the quantitative, you can have various responses. So the quantitative responses could be discrete, such as the number of children that you have, how many cars. They're exact answers. Whereas a continuous response would be something that's approximate, such as your height. In categorical, we're looking at worded responses. So we have ordinal, which is an order. So that could be true, false, very high, satisfactory, low, very low. There's an order there. Or nominal where there's no order. So we might be looking at colours. What's your favourite colour could be the question. There's no particular order when you put that down. So when you collect your data, you can have a primary source, which is first-hand or contemporary account of an event, or a secondary source. That's information that's created later by someone using normally a primary source, or information they have gathered through word of mouth. A census is a survey of every person in the population, and a sample is a survey of part of the population. And we're going to have a quick look at the different sort of ways that you can do a sample. So the sampling techniques is a random, that's where all members have an equal chance of being chosen. So Lotto's an example, you've got sort of 40 balls and they just come out in random order. Names in a hat is another example where you put everyone's name in and select one. Stratified, this is looking at categories or strata of population chosen. So you might have your school broken up into year groups, or you might be looking at sort of an age bracket, so 11 to 20, 21 to 30, 31 to 40, or it might be religion. And they're the different sort of samples that you might be gathering. It's a random selection from each category and you keep it in proportion. So if there's twice as many males as females, then you would ask twice as many males in your sample. Systematic, that's choosing, say, every 50th. You might choose every 30th. And it's an example of that is a production line. So in a production line, a company doesn't want to check every single box of matches or material that's being made. They might check every 30 minutes or every 100th to make sure that the machine is actually calibrating correctly. And the final one is called self-selected. That's where a person volunteers to be a part of the sample. So discrete probability distribution. This is where the sample space is listed in some order. It has to be numeric and it's non-negative and has to add to 1. So an example is if we toss 5 coins and we recorded the number of tails. So the chances of getting no tails is 1 in 32, 1 tail is 5 in 32, etc. Notice that the probabilities all add up to 1, that bottom row. Please note that it is not a uniform sample space as the outcomes are not equally likely. Second type is random variables. So a random experiment was when we had the 5 coins tossed and recording the number of outcomes. So there's more than one possible outcome to get. Deterministic experiment would be if we put those 5 coins in a hat and we just counted the number of coins. There's only one possible outcome, that's 5 coins. A random variable x, where x is the number of tails when 5 coins are tossed. So this is going to be something we're going to use quite regularly. So keep this in mind. So the probability of x equals 4 is 5 in 32. The probability that x is greater than 3, so that means that we're going to get 4 or 5 tails. That is where we add the 5 over 32 and the 1 over 32 to get 6 over 32 or 3 in 16. Note that once again the sum of that bottom row equals to 1. Third one, uniform discrete probability distributions. This is when all the outcomes have the same probability, such as rolling a die. So all the numbers have a chance of 1 in 6. The sum equals to 1. So the fourth type is an infinite sample space. If you've never played the game of Ludo, it's a game where you need to roll a 6 on a die to get started. So if we look at the first roll, you've got a 1 in 6 chance that you get started the first time you roll it. If we look at the second roll, so you don't get started on the first, it takes you 2 rolls. So it's a 5 in 6 on the first roll because you didn't get a 6 times 1 in 6. So that's 5 in 36. Third roll is you didn't get started on the first 2, so it took you to the third roll. So it's 5 in 6 times 5 in 6 times 1 in 6, which is 25 on 216, and etc. All the way, so you can see the fourth roll, all the way to an infinite amount of rolls. So the nth roll would be the 1 in 6, which is the one that you finally get it on, but the 5 in 6 to the power of however many rolls it takes before that roll to actually get it. That sum will always equal to 1 no matter what. The fifth one is continuous probability distributions. So this is a closed interval, say between 1 and 6, it might be between 1 and 100. The sample space is infinite and cannot be listed, as the values could be 2.317, etc. It could be an infinite amount of possibilities. To calculate this requires integration, and this is part of the Year 12 course, so it's just a bit of information for us to look at the moment. Thank you.